Hi all, welcome to another session on Azure for Data Engineers. This is session 2 on Azure Data Factory. In the session 1, we saw an introduction to Azure Data Factory and we also created our first pipeline. We will continue to discuss more about ADF, and in this session, we will be focusing more on storages. So this is the first pipeline that we have built where we were bringing data from source, which is Azure Blob Storage, into Azure SQL database. For this demo purpose, we have looked into a scenario where we work for a company, a manufacturing company where vendors supply the contract hire related information in Azure Blob Storage, and our job as a data engineer was to make this data available in Azure SQL database. Let's continue with that same example. Now that there is a new requirement, some other department within your company need access to this contents of this file, the contract hire file, and they don't have access to Azure SQL database, but they do have access to Azure Data Lake. That is their centralized location. If you want to know more about Azure Blob Storage versus Azure Data Lake, you can check out the video in the Azure Core Concepts section. So yeah, as a data engineer, you have access to this Azure Blob Storage where the files land, and there is also an Azure Data Lake which is accessible to your end user. So this time we are going to deal with a new destination. So let me first diagrammatically show this pipeline. Again, we start simple and then we will add on to that pipeline and add more complexity so that we can cover more concepts. So the source is going to be the same, Azure Blob Storage. Here we will be getting our files. Let's add more files. So we will, multiple vendors will be putting their files in here. So our destination is going to be Azure Data Lake. So this is going to be our destination. Azure Data Lake. Okay. Again, to facilitate this flow of data from one storage, here we are moving from one storage to an SQL database. Here we are moving from one storage to another storage. And in Azure Data Lake, as you already know, we can organize our data into folders. So we can have multiple folders. Let me use a rectangle here. So this can be called raw. Then we can have something called curated. So after performing the data cleaning, you can have it as curated data. You can have multiple folders. You can have something called archive. So first we will put the data into the raw folder, and that particular team has dedicated data analysts who will take care of moving the data from there. So your job is just to get this data available in the raw folder of Azure Data Lake. And again, another thing is the vendors will be providing the file as CSV files, but your end user are going to, suppose let's assume that your end user is going to use Azure Databricks or some other service for working with that file, then CSV is not a good optimal storage format. So Another requirement is that when you're storing this file into the raw folder, you want this to be converted into Parquet file, which is a columnar format. I'll be doing a separate video on comparing the different file formats and what are the advantages when to choose which format. I'll add the link to the description below. You can check that out. So in this particular project at hand, your requirement is you will be receiving CSV files in your Azure blob storage. This is done by your vendors, and you need to facilitate the movement of data into raw folder within your data lake as Parquet file. So let's get an arrow. Okay, so that's what we are gonna do. So again, to facilitate data movement, we need ADF. So we are gonna have an ADF. Within this ADF, we need to connect to this Azure blob storage. So for that, we need, you might already be guessing, we need a link service. So to establish the connection with the source link service. Then we also need to establish a connection with the destination. So we can call that um, destination link service. Now that we have established the connection, we need to specify more details about the source, like what kind of data format. Here it is CSV file, and where to find that data. Those kind of details you can specify using data set. So for source, we need to specify a data set. So we need to create a data set. And similarly for the destination also, we need to specify it should go into the raw folder. So those kind of details we specify in the data set. The fact that it's going to be a Parquet file and it should land in the raw folder, those kind of details we specify in the data set. Once all these requirements, prerequisites are ready, the final step is going to be building our pipeline. So this pipeline, we should add the appropriate activity that will facilitate the movement of data from source to destination. All right, let's go to our Azure portal and start building our pipeline. So if you don't know how to find your data factory, as it is the second session, I'll show it again. In the Azure portal, you can access the Azure portal using portal.azure.com, and once you are logged in, you just need to search for Azure Data Factory here. It's available as a shortcut here. You can directly click here as well, and you choose the uh, appropriate data factory. This is the one that we were working on, and then you click on the Launch Studio so that you can open the Azure Data Factory Studio where you can do the development. So we will be doing the pipeline development under the Other tab. Currently we have one pipeline, the one that we have built in our last class, which was moving data from blob storage into SQL database table. So let's look at what are the components we need. Going back to our diagrammatic representation, we need the link set to connect to the source, which is the blob storage. So in our earlier pipeline, the one that we have built in the last class, we have already created a link service. Link services we can find under Manage tab. If you go to link service, you can see that I already have a link service to the blob container. You can verify whether it's working by clicking on the test connection. So this is looking good. So definitely we can reuse that link service. We don't have to create a link service because we already have a link service to the Azure Blob Storage. So when you're working on actual project in a company, again, this will be the case. You don't have to build everything from scratch. Try to reuse as much as possible and only create those that are absolutely necessary. Okay, now source data set. Source data set, let's check. So data set, we can come to the other tab under data set. We have a data set for blob. Okay, so it's pointing to the inbound container, and yeah, first row as header is checked, so we have the appropriate settings for the source, so this is good as well. So these two we don't have to do because we can reuse what is already created for our last pipeline or for our existing pipeline. Now the destination, this is the first time we are dealing with Azure Data Lake. So definitely first we need to create a link service so that we can connect to this data lake. So to create a link service, come to Manage tab. Under Link Service, click on New, and what kind of destination? It is a data lake. So look for data lake, Azure Data Lake Storage Gen 2. This is the one. Click on Continue, and you need to give it a name. So as it is a link service, I'll prefix it with link service, and it's to ADLS, and it's related to contract hire project. So yeah, I'll give it that name. Then I'll choose from Azure subscription, and I'll choose my subscription, and it will list all the storage accounts. So storage account, Algorithm ADF demo. This is the storage account. Let me show you that storage account. So you can check for storage accounts. This is the storage account here, and you can go to the containers to get more details. Okay. Algorithm data lake 1. So this is the container. So we can fill in those details later on. First, we just need to point to the appropriate not source, in this case it's destination. So we just need to specify the storage account name. The other details we can specify while creating the data set. So let's do test connection. Connection successful. So click on create, so that it will create the link service. So we have completed this step. Next one, we have to create a data set. Here we are going to store it into the raw folder as Parquet file. So let's see how to do that. So let's go back to the other tab, and here we have data set for the source. This is the one from previous pipeline. Let's create a new data set. So under data set, click on here, the three dots, new data set. So here first we need to specify what is the destination or where this data set is. So it's a data lake. So type that, you get data lake. Next you need to specify the file format. For destination, we need Parquet, so choose Parquet as the file format and click on continue. And we need to give a name for the data set. So DS, I will say Azure Data Lake Storage, ADLS, and I'll specify the format as well, Parquet. And specify the project as well. And it need the link service. So we already have created the link service. If you haven't created the link service, you have the option to create link service from here as well. Okay, so as I have already created the link service, I'll choose that one, the one we just created, and you can click on OK, or you can add the parameters here. So file system, let's go back to our link service, sorry, the data lake. This is the container name. So you need to come to data storage and containers. So Algorithm data lake 1, this is the container name. So that you need to specify as the file system Algorithm data lake 1. And then within that, if you click inside the container, you can see separate folders for raw. There's nothing inside that folder, but you can go back to the container. So within this container, we have raw, curated, analytics, separate folders. So we want our data to come into raw folder, and I want to create a folder named contract hire. I'll remove contract hire from here so that it will be generic. And within this data lake, within the raw folder, um, I'll create another subfolder contract hire, and within that I can put all those files. So let me click OK. Try this. Okay, specified path does not exist. So I think if I'm specifying it in here, I need to create the folder. Let me try it this way. Okay. Okay, that's fine. So for now, we will just land it to the raw folder. So the data set is created. So let's go back to our diagram. We have the source and destination link services. We have source and destination data set. Data set. And next step is building the pipeline. So for building the pipeline, we need to come here, new pipeline, and we can give it a name, pipeline, contract hire load to ADLS. Okay, now within this pipeline, we specify what are the steps we need to do. So for now, we are looking at only one step, which is moving data from source to destination. So for moving data, we can go to the move and transform section and use the copy data activity. This is the same activity we have used in our previous pipeline as well, but we just need to appropriately provide the source and sync parameters. So first give it a meaningful name, copy from blob to ADLS. That's what we are going to do here. And I want this to be activated, and let's leave everything else to the default settings. Then we need to specify the source data set. Again, if you haven't created the data set from here, you can also click on this new, and it will show the same UI where you can specify the dataset details and do it as well. I prefer it this way. Go to this section and do the dataset. It's individual preference. Okay, so as I already have the dataset created, I'll choose that one. So this is source. Source is going to be a dataset blob. Okay, and if I go to the source, let me open another tab, and this one is the data lake. Here inside raw, there is nothing as of now. Let me also show you the source. This is our source, and again go to data storage, containers. There's a container named inbound. I have 4 files in this inbound container. So I want to load all the files available in this particular container, all the files that ends with .csv. So what you can do is you can specify a specific file path in the data set. I'm not doing that. What I'm going to do is wildcard file path. I'm going to choose that option. So inside the inbound container, anything that ends with this .csv. The starting can be anything. That's why I put a star as a regular expression and ending with .csv. So this will load everything that ends with .csv within this particular container. So these are the source settings, and I want it to do recursively process all files in the input folder and any subfolders if any. That's good. Now that I have defined what is the source, the left side is clear. Now we need to specify the right side. So the sink is going to be data lake, and it's a Parquet file. So I'll choose the dataset I have created for that, and we can leave everything to the default. So in the data set, we have specified that it should land into this particular container and this particular folder. Okay, now let me click validate to see whether there is any errors, issues. I don't see any errors. Now let's go back to the pipeline and blob to ADLS. Let me debug this. So if I want to quickly run and see whether everything is working, I can click on the debug. Once everything is finalized, I'll add trigger so that it will automatically do based on what kind of trigger we set. So it will take a few seconds to um, run, and it will be using the Azure runtime, the default one that is available. Okay, it shows succeeded. So the input was uh, the source is Azure Blob Storage, and we have specified star.csv. Sink is Parquet sink. Okay, if we look at the output settings, so total data read is this much, and total number of files 4, files returned. So these two numbers are same. So that means we didn't miss anything. There was no errors. You can also look at these glasses for getting more details. Here also we can see the status, number of files, number of kilobytes read, all those kind of details. Okay, so we can do the verification by checking the data lake. Let's go to the raw folder. Here we can see that all the 4 files have been loaded. So if we schedule it to run every day it will check and it will load all the files in the blob into this particular data lake folder. Now that we have built our simple pipeline, it's time to do some optimization. We need to make this pipeline scalable. So this is not just a one-time ad hoc request. Every month, the vendors are going to send files, different vendors, and we need to load those files. So to make this more scalable, let's see what we can do. One optimization we can do is instead of loading all the files directly here, we can add more subfolders. For example, a folder for every year and then another subfolder for month. So those kind of optimization we can do. So let's see how to do that. So what we can do is we can go to our data set. So this is our data set. Here we have specified raw. What we can do is there is this feature called add dynamic content. So we can add expressions and we can add dynamic content so that depending on when this pipeline is running, it will automatically create folder if needed and put the file in the appropriate folder. That kind of facility we have here. So let's see how to do that. So what you can do is you click on this. Let's remove this raw from here. Click on add dynamic content, and this is where we put our dynamic content. So what we need is we need to have uh, this inside. Let me show you something here. The folder structure I'm looking for is raw, and inside that I want the year, for example 2025, and then month, and then I want the file to be available there. So let's see how to build that. So what we can do is we need to concatenate multiple strings in order to achieve this. So what I can do is I can use the concat function. So it accepts a list of string and it returns a string. So I'm using the concat function, and the first argument is going to be raw. I can even do something like raw contract hire as well. Just to show you, you can specify multiple folders by just using these slashes. Then we need okay, I can put the slash here. Okay, inside contract for hire, now I need, depending on when this pipeline is running, I want the year. So to find out when this pipeline is running, we can use some function called UTC now. There are so many functions available for our use case. We can use this function, but this will give the entire, like the current timestamp. It shows the description, return the current timestamp. I don't want a folder for every timestamp. I only need the for the first level I only need the year. So what we can do is we can pass this value to another function called let me cut this. There's another function called format date time, something like that. Yeah. So to this function, what we want to format is the current timestamp, and how we want to format is I only want to get the year. So I can specify something like this. So this will give me folder structure like this: raw slash, sorry, contract hire slash 2025. Now I need the month. So to get the month part, let's go back here. I can add a comma. The next item is going to be again same format date time UGC now, and this time I only need the month. And then I also need, okay, after the year we need a slash, otherwise these two strings will just simply get concatenated. So currently what I have is this. Let me add something like this. Okay, then I have the year, so 2025. Then I'm directly giving the month 09. This is not what I want. I want a slash in between. So I can add a slash like this. And again, after month also I need a slash. So we need to specify a slash here. Okay, then the file name we are specifying using wildcard. For the source, so whatever file name was there in the source, it will get that. Okay, why it's giving an error? I missed a comma. Okay, so the concat function is used to concatenate multiple strings. So this is one string. Before specifying the next string, you need to provide a comma. This output is going to be another string, which is going to be the year. Then comma, Then we need to add a slash, comma. So you can specify more than one string, a list of string values separated by comma. So that is what this concat function will be expecting. Okay, let me click on OK, and let me go back to our data lake and let me delete all these just to clean up. So we have a raw, there's nothing inside our raw. Our source still have all the 4 files, and we have updated our data set. Now the data set, let's try to debug the pipeline and see. Let's do the validation first so that we will catch up any errors. Okay, validation seems to be okay. Now let's click on debug and wait for the pipeline run results. Okay, for some reason while waiting for it, you have clicked somewhere else and you lost how to check that pipeline output. There is another way you can check the pipeline output. You can go to Monitor tab, go to Pipeline Runs, and under Debug Run, you can see. So all the scheduled trigger runs will come here. We don't have any triggers yet. So you come to Debug Run, and you can see it's succeeded. And let's click on that pipeline, and we can see the details. 4 files got read and 4 files got returned. Let's check our data factory. Now we can see, so when we directly try to specify contract hire, when there was no contract hire folder, it was giving an error, but inside the concat function, when we provided it, it dynamically created the folder when it was not there. And there is a folder for 2025, there's a folder for 09. Inside that folder, all the files got saved, and check the file format. It's Parquet file. The source files were CSV. So Parquet format files are not readable directly, so I cannot show it to you, but it is good for other programs like Databricks or AWS, Athena, those kind of um, uh, services. If you are going to use, you can check the size here, 56 kilobytes. In the source, it's more than 100 kilobytes. So the size is reduced to half. So as the files become more and more bigger, the amount of storage savings you get will be really significant. That is why for big data scenarios, Parquet file format is preferred. Okay, now let's add one more additional feature here. So far what we are doing is we are moving the file from our source into destination inside raw, and we are dynamically creating appropriate folder structure and putting the files in there. Suppose there is another requirement. We also want to store these files into archive folder, because from raw folder the files could get modified. If you're working for some financial services company, or where strict auditing or compliance requirements are there, it's always a good practice to keep a copy of the files as they are received, without you touching it, without you making any modification. And as such copy of the file, sometimes there will be regulatory requirements that you need to keep such a copy for a specific period of time. So for that purpose, we can add the flow. After we copy the file into raw, we also put a copy into archive folder. So into the raw folder, we stored it as Parquet file, but we don't want to make any modifications. We want to store the file as such into the archive folder. So let's see how to add that feature. Let's go back to our pipeline under the other tab. Okay, so this is our pipeline now. So let's look at this copy data activity. At the end, we have four different options. So a pipeline means, so far in all the pipeline examples we have seen, we have added only one activity. But a single pipeline can have more than one activity. So what we are trying to achieve is, after copying the data to ADLS raw folder, we also want to copy into ADLS archive folder. So what we can do is same kind of flow, moving data from one place to another. So for that we can use another copy data activity. We can put it here, and then we need to specify the source and destination. And we can also, if you put it like this, then these two activities may run in parallel. If you don't want that, then there is some way to control the flow. You can, if you hover over here, you can see on skip, on success. So in our case, once this activity is complete and it's successful, then we want the file to be copied into archive folder. Because if it is failed, then there might be some issues with the error file, and we may contact the vendor and they may upload another file. So we don't want to unnecessarily archive those files. Only those files we are copying into raw folder, we want to archive them. So in our use case, we can use on success and drag an arrow and put it there. Let me delete it and show you one more time. Start from here, click and drop your mouse arrow when you reach here. Okay, if you want something to happen, say for example, you want to send an email when this activity fails, then you can drag and drop it into an activity that sends email. We can check into something like that later. Or if you want to um, notify or update some database table when there is a failure, you can do that. Or regardless of the outcome, whether it is success or failure, you want another activity to happen. That is what you use this on completion flow. There is also another flow on skip. So for some reason, if this activity is skipped, then you want another activity to happen. So in this way, you can make use of these four different options to add different activities and connect them, control the dependencies. So the most common used ones are on success and on failure. Just it is good to know that there is two other flows are available as well. Okay, so now that we have defined another copy data activity, for this one we need to set up the configuration or parameters. First of all, let's give it a meaningful name. We can name it archive files. Okay, and in here we can keep everything else to the default settings. Now we need to define the source. Let me choose the source as the existing source that we have been using, the blob. And we can deal with any errors later. If any errors happen, I want to show it live and deal with it. That's why. Okay, so this is going to be a CSV blob file is our source, and in that container named inbound, we want to look for all CSV files. So that's why I'm using wildcard path here. And for the sync, again, we are going to load into ADLS. So we do have an ADLS dataset, but that is for Parquet. We don't want to store as Parquet. We want to store it as such. So the industry standard practice, if you want to store something as such without passing it, without converting it, then you should use binary. So binary format means blob exactly as such, without reading the contents, without reading the schema and modifying anything. It will exactly make a copy of it and put it there. So that is the behavior we are looking for, and we don't have a data set with binary as the file format, so we can create one from here. This time let's create from here. So first we need to specify what is the destination. It is a data lake. So I'll type data lake. Okay. And then select format. Here we can see binary format is available. We already have created one with Parquet. This time we are creating one with binary. And now we need to give it a name. So dataset ADLS, and it's going to be a binary. Then in order to connect through the ADLS, we need the link service. Link service we can reuse. It's just that connection to a specific Azure Data Lake storage. So we can use this link service. And again, this one I will fill in later. For now, I'm going to click OK. So I just wanted to show you how you can create a data set from here as well. In the previous sessions, we have created a data set from here. We went to this particular section. So the one we just created, you can see that one appearing here as well. So if you want to make more modifications, you can come here and it will open up a new tab. Here you can make those modifications. So what I want to do is, again, we need to specify the file system. So I'm gonna go check here. So this is the file system, the existing Parquet ADLS dataset. I'm gonna use the same. Again, archive also, I want to do something similar. So I'm gonna copy that and I'm coming here. Click here, click, don't paste it directly here. Sometimes you may run into issues. So click on add dynamic content and paste it here. And instead of raw, you want it to go to the archive folder. So going back to my ADLS, inside the container, I don't have an archive folder, but it's okay. When you specify it inside this dynamic content, it will create that folder if it doesn't exist. So inside AL DL1, inside archive, contract hire, then a folder for year and month, and those files will be copied over there. Okay. Now that we have specified those details, file name we don't have to specify. It will automatically use the file name from source end. Okay, that's good. Now let's come back to our pipeline. So we have the source and sink. Those are the essential settings. So we have filled in all the essential settings. Let's do a validation. Now we can see usually when there is no issues, this will be empty. Now we have an issue. Source must be binary when sink is binary dataset. So we were trying to reuse our source dataset for this activity. The sink is a binary dataset, so it's complaining that in such case, source should also be a binary dataset. Here what we have is a CSV dataset. So what you can do is you can remove this. I can create one from here. So the source is Azure Blob. So let me type blob here. And we will create a binary dataset for the source. So the link service should be blob. Earlier, when we were creating the dataset, we used link service for the ADLS, which is the destination. Now the source is blob. Okay, so this blob I have chosen. I need to give it a name. So dataset blob binary. Okay, the container is what is the source? Inbound. Yeah, inbound is the name of the container. And this we can leave it blank. We have the files directly inside this container, so everything else, if you have like directory like structure within the names, you can specify that here. Okay, now let me do the validation again. Now your data factory has been validated, no errors were found, all good. So let's do our testing. Before that, let me go to the raw folder and let me delete this. This is created from my previous debug run. So yeah, now let me go back here and run again, and see what's happening. So I'll pause for a minute and come back when it's ready. Okay, now the pipeline run is completed. We can see when your pipeline have more than one activities, you can see all the activities. In the previous runs, we saw only one row here. Now we have two activities. One is a copy from blob to ADLS, then archive files. And you can check the details of individual activities by clicking those details icon here. So both the jobs have copied 4 files, and let's verify that by going to our data lake. So if we go to the raw folder here, again I have deleted it, but we can see that it's created again. All the 4 files have been copied here, and there was no archive folder earlier. Now it has created an archive folder, and following the similar folder structure, this time inside the archive folder the files are .csv. The size is 101, just like the source. 101 blob type is blob. Okay, let's go back to raw folder. In the raw folder, the size is 56 KB and it's Parquet file. So far what we have seen is using Azure Data Factory, how we can move data from one type of storage to another type of storage, and also how we can move data into a different format, how we can play with different formats, and what are the requirements. When you want to store it in different format, you need to create a separate data set, but you can reuse the same linked service because the connection is the same. Within that connection to ADLS or blob, the way we handle the file, only the file format is changing. In such case, you only need to create new data set. Now let's add one more activity. Now that we have archived the files, the vendors keep putting more files here. So next time this pipeline runs, it's gonna copy these files again. We don't want that to happen. So let's add one more activity. Once these two steps are completed, we want the files from the source to be deleted as well. So for that, we have a delete activity that we can utilize. Let's add that to our pipeline. So we can move things around here. Maybe I'll hide the properties. Okay, delete. So again, we can choose when you want this activity to happen. You don't want this to happen in parallel. If you don't connect with arrows, as soon as this activity start, this one also start. So before archiving, we will end up deleting file. So definitely you want to connect it with on success. Only after successfully archiving files, we need to delete. And for the delete activity, again you can specify the source data set. Let's choose the blob CSV one, and wildcard file path, and use star.csv. Okay, so recursively means everything inside this folder will get deleted. And logging settings, for now, to make it simple, we can turn off logging. Otherwise we need to add more settings there. So I just wanted you to get familiar with this concept for now. Okay, so we have added the delete activity as well. Let me go back to my Azure pipeline. Yeah, let's see without deleting it what happened. I'll delete it from raw folder. I'll keep it in the archive folder, and let's see what is going to be the behavior. Okay, so again, if I do the debug, first let me validate it, and then there is no errors. That's good. Now if I run it, all these three activities will get executed again. So copy from blob to ADLS, then archiving files, and then deleting file. So let me run the debug. Again, I'm going to take a pause and I'll come back once it's complete. I also wanted to show you that um, these activities are getting executed one by one because we have defined dependencies, and we can see that one activity is complete and the other one is queued. So this the flow we have defined here is a sequential execution. Now the second one is complete and the third activity delete is being queued and it's getting executed. Let's just give it a few more seconds and then we will check the results. Okay. Files deleted 4 and files read 4, files written 4. So this is how we check the statistics. And again, this is to copy from blob to the ADLS. Let's check the storage account. So those 4 files, they are not there anymore. This is the blob. Let's check our ADLS. And ADLS, we can see archive has the files with the current timestamp, and if you go here into the raw folder has the files in Parquet format. So in summary, in this session we have seen how to carry out multiple steps, more than one activities within a single pipeline, and how we can control the dependency of these tasks. If you want one task to be done after other, we can use these control flow paths to control that flow, so that if you don't specify this, these both activities will happen in parallel. With this flow, only after this is successful, this one will get executed. If this is not successful, if this one is failed, then this particular step will not get executed. Then we have also seen how to create data set and how to add dynamic content in our data set, so that based on the time when this pipeline get executed, the pipeline will automatically or dynamically create folders, and it will copy the files accordingly. So what I'm going to do is, let me try to intentionally fail one of the activities. Okay, this is a CSV. Blob contract hire. I'm just gonna add an S so that there is no such file path, and see how the pipeline is gonna behave. Okay, let me debug. If you want to create another pipeline that is kind of similar to this pipeline, you have this option. You can click these 3 dots here and click on clone, so that it will create a similar pipeline, and the new pipeline has the name copy. Okay, let's go back to our original pipeline, and you can see that the first activity has failed. So as a result, the second and third activity didn't get executed, because only on success this will get executed. So if instead of on failure, if we had some other thing to happen, then um, so let's see, we have this activity called set variable. So just to show you the flow, what I'll do is I'll have this set variable activity and connect them here. So on failure, what it will do is it will execute this activity here. I'm gonna create a new variable. So the mandatory settings are, we just have to create a new variable. I'll call it job status and type is string, and I will set it to failure, just for demoing that this particular activity got executed. Okay, now let me debug this pipeline. While waiting for it to finish, let's go to our clone, and I'm gonna remove this dependency, and I'm gonna have this two activities hanging out there, and we'll come back there. Okay, let's see whether it has completed. Okay, so you can see that the copy from blob to ADLS has failed, and after that the set variable activity was getting executed. It is successful, it has set the value of the variable. So job status variable value is set to failure. These two activities didn't get executed because it is on the success path, on success path. So this is how we can chain multiple activities together and control the flow of what gets to execute and under what conditions they get to execute. Now going back to our clone, I'm just gonna run this as well. Let me correct the error in the data set. Okay, now going back to our pipeline, let me debug this. I'm not sure whether it will be that obvious. Let's see. Let's wait for the execution. Can press the refresh. Okay, these two activities got executed together. I should have pressed the refresh earlier because there is no path between them. So if you want set of activities to be executed simultaneously without any connectors in between, you just have them here in the pipeline so that they will get executed simultaneously. If you have noticed, in the earlier pipelines, only after this one finishes, this one will start. But in this pipeline, these two activities started execution together. They got executed together. If you check the run start time, you can verify it. They both got executed, started execution at the same time. And let's go to the monitor tab and debug run, and we can check the uh, other pipelines. So let's look at one of our earlier pipelines. This has three activities. So first activity 27, then only after it got completed the next one got executed, and only after it got completed the next activity got executed. But for our recent one, because we didn't have that connection path, these both got executed, started their execution at the same time. Okay, so that's everything for this session. We have covered quite some ground. We have seen how to move data between different storage and how to move data, how to do conversion of data as well, and how to preserve the data, like how to preserve the file as is using binary format, how to save storage and eventually some processing time using Parquet format, and how to archive files. So stay tuned for the next session where we will talk more about databases and storage and how we can organize it using Azure Data Factory. Thanks for watching.